Hello guys, it's Kenny once again. All right, so today we shall be looking at a type of variable container, so to say, that is the set in Python. So what do I call a set? No, it's something like the list in Python, and you may also say it has some similarities with Python. We've looked at list and we've looked at say tuples, right? Okay, so it's that type of container that you use to hold multiple values. So it's not just a single value as you would in a normal or typical variable. So you know how we could have, say, my var. Okay, let me share my screen, guys. So we can have my var, and I would give it a value of 4, right? So that's just the normal variable, the normal container. But say I wanted to have like multiple values and I want to still store all of them in a single variable. So I could create something like this. So I could say 4, 5, 6, right? Now, this here is what you call a set, right? Now, you see that it's different from a list. If I wanted to create a list, I could have something like this now, square brackets, 2, 3, 2, 3, 4. So here is a list. So guys, there's a video on Python list and Python tuples, right? You can watch the videos and get yourselves familiar with tuples and lists. But today we want to focus on sets. So what are the features and how do we create a set? I have already done that here now, guys. My var, okay, let me just call this my var. So my var is a set. Guys, take note of the curly brace here and the curly brace here. And in between the two curly braces, you have the values separated by commas. Now, if I wish to know if it is truly a set, I could just get the type. So what type of variable is it, or what type of data would that be? I would simply say print. So let's use the type method, type. So within that, I will just have the argument as the set. So let's see what that returns. Class is set. So we see that my var, sorry guys, my var is a type of set. All right, so that's how you create a set. Now, another way to go about it is to use the set constructor. That is a method that actually does the construction of that object. In this case now, a set, right? So I will have my var2, create another set. And this time, I will call the set constructor. And please, I would, in this case, use double parentheses. So that should be 4, 5, and 6 this time. Okay, so now let's check what type of data it is. Print, this should be my var2. Print my var2. Now what type of data? So I need to put that as argument for the type method. Okay, so that done, let's see. So that's also a set there, guys. So those are the two ways of constructing or making a set. Let's go to the features. What are the features of the set in Python? Right. The first is a set. First and foremost, guys, is not the values within a set are not ordered. So each time you call that set and say you have 3, 4, and 5, the first time, when you call it a second time, it could just, it would be or possibly be rearranged. So it could not have 5, 5, 3, 4. And the next time could be 4, 5, 3, just like that. So the values are not in any particular order. That's one thing about the set, unordered and unindexed. So you can't say that 3 is at position 0, because when you want to use this set, for example, the 3 may have moved to another position. So you can't possibly claim that 3 will always take the index 0, starting from the beginning. So this is index 0. It may not always be occupied by the 3 here. So we say that it is unordered and is not indexed, right? Then, guys, another thing about the set is that you can't have multiple, you can't have duplicate values in a set. Let's see, guys. So I'll just simply create a set here, my var, and within that, 3, 4, 5, 3, 6. So we see that 3 occurs twice, right? 3 and 3 there. Now let's print out my var, print my var. We'll see what that gives us. So I'm going to run 3, 4, 5, 6. So we see that it just ignores this second value here. It takes only these first 3. So that's just what it is, guys. Duplicates aren't allowed in sets. Let's take note of that. So those are the things about sets that we should know. Then finally, guys, we cannot alter a set in terms of changing the values in it. The values are unchangeable. So I can't have something like, the way I would if I had a set. If I had a list, my var, and based on the position, say position 0, in that case, the first value there, and set it to say 9. Then I'll print my var and see if 9 takes the first position there. Print my var. And let's see, guys. It raises an error. It says set object does not support item assignments. That's at this point. We can't assign a new value to a set where the position is already occupied by another value. So I'm trying to change the number at position 0, which is 3. I'm trying to change this 3 to 9, and we are told that that is not legit. So that's it, guys. You can't change the values already within a set. However, you can add and remove values. So we'll come to that. You can add and remove values within a set. We'll come to all that as we proceed. All right. So guys, let's see. We've looked at how to create a set, and we've looked at the features of a set. And how about accessing values in a set? We've just seen that we cannot use the position of a value to get that value. It's not going to work because no value stays permanently in a particular position. So you can't grab any value based on its position. That's the thing about the set. But we can only just say with every sense of certainty that a particular value exists in a set. And that's using the membership operator. So if it exists, we know that it is true. And then if it doesn't exist, we know that it is false. So now, guys, let's see. I in, okay, let me see, that's not I, let me say Ada in MSET 4. So this MSET 4 here, this set here, MSET 4. So that will be either true or false. In other words, is Ada in MSET 4? So can we find Ada as any of the values here? And we'll store that. Let's just store that in a variable. Let me say variable check. All right. So now let's see, print and find what's returned. Check. What's that going to be? True. So yes, guys, we can say for sure that Ada exists in M set 4. Now, what if I change this to Kunle and run this? You see that it's false. There's no Kunle in M set 4. So that's how you can just kind of check if you can access the values, not by actually being able to get those values at their different positions, but to just determine if it exists or does not exist in the set. You know, that's the most you can do with sets in terms of accessing values. All right. So guys, we go to changing. How do we change the values within a set? We've just seen that you can't change the values, right? What if I changed that set to a list and changed the position, then converted the new list back to a set? Would that work? So guys, let's see if that's possible. So I'm going to use mset4. mset4, the same variable name, and then convert that to a, using the list constructor, convert that to a list, right? So mset4 is now a list, just as simple as that. And I can change because items in a list are changeable. So I can assign new, assign a number to a set to a given position. So mset4 at position 0, that will be, what should I assign then now? Let me now say Kunle. Okay, right. So guys, let me print. As of this time, mset4 is now a list. It's a list, guys. So now let's see what we have in mset4 as of now. So yes, you see that Kunle is now taking the place of Ada. Now I can now simply change mset4 back to a, can change mset4 back to a set. So using the set constructor, I would simply provide the argument there and print mset4. Okay, so guys, if you go through, you see that Kunle is now at position, Kunle is now at position 0. Okay, but if I call this again, it may just be taken to another position, right? It may just be taken to another position. So let's see. So we see here now that Kunle has moved from the first position to, another position. I hope you understand, guys, what's actually happening. Okay. And we realize, guys, that again, Kunle has come to the first position. So we can just, keep doing this again and again and again and again. How many values here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So what you might wonder, why does Ada appear here when I have substituted Kunle for Ada, right? So instead of Ada, I should have Kunle at this position. But each time I run the program, this set is created and Ada, before it is changed to a list, Ada is taken to another position, it may just be taken to another position. So what is actually at position 0 before I convert to a list may not be Ada, it may just be some other value. I hope you understand it. So it appears to be Ada, but when I am to use it, like changing it to a list, Ada may have been moved to another position. So it's some other value that will now be at this position, right? At position 0. That is why it is not the case like all the time that it is this adder that will be taken off, like changed. So this Kunle can replace any of the previously held values. I hope you understand, guys. Okay, so let's continue. So that's all about changing values, you know. Can I now copy? That is, just take a set and place it in another set. How about that? So guys, let's see. Let me just call this MS. Yeah, just my set, MS. And I want to copy M set here. Now I'm going to use a method, a set method called copy. And it's going to take no argument because it's just going to copy that, right? And return that copy. So if I print MS, I should see the same values in MS, in M set rather. Okay, so that's that, guys. You see that M set has been copied, you know, into MS. Right, so that's the copy method there. What if I want to add? You know, remember we said that we cannot change the items in the list, but we can add or remove. So if I wanted to add, it's as simple as that. I just simply use the add. Add, M sets add, right? Now, what do I want to add? A value. So I may just add no 6 in M set, so I can just add 6, right? And then just get M set. Okay, so that's it, guys. We see that 6 has been added to it. Now, it's not compulsory that it is not always the case that 6 will be the last value there. If I use that again, Okay, so 6 has now been moved. So I'm just trying to show us that when you place the values in a set, like at creation, when you are to use that set for anything, it is not always the case that those values will be in their original positions. That's what I'm trying to say. Okay, guys. So that's that for adding. What if I wanted to update a set? What if I wish to update the set, right? How do I do that? Yeah, the word there is update. So I'm just simply going to update my set, that same set. So this time I want to update mset2, and I'll use the update method there. And what's the thing? What do I want to update? That is, what do I want to change there? Is it like I want to bring in new stuff to it? So I can now create a set inside of of that update parenthesis and give the values as a set. The value should be in a set. So I wish to add 10, 11, and 12. So I'm updating mset2, that is this one here. I'm updating it by adding a new set to it. Okay, all right. So now if I print mset2, what do I get? Now let's see. So we see that, you know, when you go through the members here, you will definitely find 10, 11, and 12. 10, 11, 12, you know, in no particular order. Okay, so that's it, guys, about the update method. Now, what about the union? Hey, guys, please, you can actually, you know, using updates, you can use, let's see, guys. So we see that we can actually use any iterable, like a list in this case now. So it does not have to be a set. just any tuple, a list, a tuple. So let's see, if I made this a tuple and I run, we'll see that that also works. So that's how you can use update. When update, it doesn't have to be the new information or new values. The new values do not have to be within a set. They could be in a list or a tuple, you know. All right, so that's it, guys. Now, what about union? Union, the same thing, the same principles. So I should have union there, and this time I should have a set, a proper set there. And let's see. Oh, so sorry, guys. That's keep my, I don't know. There's a difference, guys. We need to, the union returns a value, that method returns a value, a new set. So I will just call this new set. Okay, so new set, I'm going to print new set. Okay, so let's see, guys. All right, so we cannot use update exactly the same way as union. Union returns a value, and that's what a new set, which we assign to this variable new set. But you know, in other things, they are the same. You use union and update to add some more values to a set. Right. So now let's look at how to remove. How do we remove values from a set? Okay. So how do we remove values? So I can simply use the word remove, just like that, remove. I'll just say that should be mset4 dot. Now you see that there's a method called remove. Now the value that I wish to remove John. Okay, so when I print, we'll see the output there, mset4. And let's see, John remove. Can we still find John? No, John isn't present anymore. So that's it, just as simple as that. And guys, you see, it's removed in place. So you don't, it's not kind of assigned to a new variable. So just remove it in place there, and then you still have what is left in the original set. How about discard? Now, guys, I want to show us a difference now between discard and remove. Now, I want to remove Lacon. So Lacon has been removed. Now, if I run this, I'm going to have an error. Wow. So how is that possible? Line 9 in module mset4. I mean, in set mset4, we don't find Lacon. So when I'm using the remove method and it doesn't find what I'm asking that it should remove, then it's going to raise an error. If you wish to avoid that, that is, in case it doesn't find the value, it shouldn't raise an error. Then you should use the discard method. So let's try discard and see if there's any error raised. Okay, so we run. So guys, it returns the set as is. Because Lacon wasn't found, it simply did nothing to the set, no error raised. So I'll kind of, I would say it depends on your purpose anyway. You may wish that the program should just, still run even if it doesn't find the value to remove. You just remove it should just bring back, not return in this case now. It should just retain the original set. All right. Now, still progressing. Let's look at the pop. Now for the pop, you are not going to focus on the value. So the value isn't going to be the argument. It's simply going to remove whatever is at the last position. Whatever, you know, it's not just one value that will always be at the last position. The value at the last position keeps changing. So we can't say, but whatever it finds at that point that we may not know, it removes it. So that's the use of the pop, right? So when I run, we'll see what's removed in MSET4. Can we figure that out? There's Ada, there's Ray, okay, there's Scholar, there's Emmy, and no Emmy. So no Emmy. Emmy was the last when the pop method was called or used, and that's why Emmy was removed using the pop method. Now, if I run again, some other value may just be removed instead of Emmy, right? So, okay, Emmy is still missing. I'll keep doing that until I see that Emmy. All right, so now here, guys, Emmy wasn't removed, some other value. So at that point, it now shows that it wasn't Emmy at the last position. It was some other name. So what name would that be? Ada. So Ada was at the what terminal position. That was why it was. That's why it was removed. All right. So now let's look at clear. The clear method. Now, if I wish to empty the set still exists, but it's empty. Just use the clear. The name suggests it, clear. So it returns or gives you, I don't know, it's not return anyway. It outputs an empty set. That's for the clear method. What if, guys, I wish to destroy the set completely? Just like for triples, you use the del keyword like this. So MSET4 after using the del keyword would not exist. So let's see. Now it says name MSET4 is not defined. But I have MSET4 here defined, right? But how come it doesn't see it at this point? That's because it was destroyed here. All right. So that's how we use the del keyword to destroy a set. Now, moving forward, the loop can be used to go through the elements within a set. I can use a for loop, right? So I can simply say for I, which is like the tracker, for I in MSET4. Now it goes through all the values in MSET4 and prints them. So just something basic. Print I. So I will be a value within the set at any time, at any cycle, right? Okay, so if I run the program, we'll see that every member of the set is printed. Do we see? And you'd expect that Ife is the last one now. So why is Ife not the last? Because values in a set are not ordered. That's just what we need to know. Okay, right. So that's how you loop through elements in a set. There are some things I still want to discuss, you know, some methods, some set methods, the intersection. I'm going to use MSET4 and call the intersection update method. Now, what this does is this. It looks for common values or elements in MSET4 and the set that is the argument for intersection update, in this case, MSET3. So what are the common values between MSET4 and MSET3? And it will give us it will not return a new set. It will instead retain MSET4, but with the changes made. So the changes will be made in MSET4. So let's see. So if I print MSET4, we'll see that it will no longer hold all these values, but instead it will simply, sorry, mset2, this should be mset3 and mset2, guys. They are alike. So if I print mset3, we'll see what that returns. I mean, what that gives us. So we'll see, guys, there is 1 in mset3 and then in mset2. 5 is present in both, 6 is present in both, 7 is present in both. 8 is not, 8 exists only in mset3, but not in mset2. That is why 8 is not included. We need only common values. Color is in both. That's why color is included. 9 isn't and false isn't, so both are not included. So that's how you use the set intersection update, right? So, and the thing is, it recreates mset3. That is, it does not actually return a new set. It changes mset3. It changes the values in mset3. What if I wish that it should return a value? So, I mean, it should return a new set. Then I am not going to use this update here. Just mset3 intersection mset2. Then I can now, it returns a new set, which I will store in a variable called new set, right? And then I can now print new set. Okay, so that's it. So I can now work with new sets anywhere. Right. What about the difference between difference and difference updates? Actually, what do the two of them do? What are they used for? Now, as the name suggests, difference. What's the difference between elements? Not the common values. That is, what is in A that is not in B? Return only those ones. What's in A that is not in B? Those missing in B that you find in A, those are the values we want in a set. Okay. So if I use mset2 and mset3, anything that occurs in both, I'm not going to take. So here I see that 8 occurs in mset3. So if I had this now, mset3 dot difference as a method, difference is a method there, and the argument is the second set that I want to compare, you know, to see if the values in it are not found in the other one. So mset3 and then mset2. Now what this is going to do is that it's going to take mset3 for every value in mset3. So 1, it checks if there's 1 in the other set, which is mset2. It finds it, then it discards it. 2 is there, 3 there, 6 in both, 7 in both, then 8 is in mset3 but not in mset2. So it takes 8, it keeps 8. Color in both, no. And then in mset3, I can see false. False is not in mset2. So the 2 you find in mset3 but not in mset2 are 8 and false. It's not going to do anything with this 9. Remember, this is like what is going to use. It is the values in mset3 that is going to use to do the checking. So even though there is 9 in mset2, but it's not in mset3, it's not going to make any difference. It's still going to discard the 9. So let's be careful with that. Now, if I print mset3, let me print mset3. We'll see that we'll have just 8 and false. mset2 and mset3. Why is that? Sorry, guys, just give me a moment. mset3 and mset2. 1, 2. Okay. Oh, sorry guys. This here, please, we need to create a new variable because it's going to return a new set. That was just the problem. It will return a new set there. So if I print new set, we'll see that that should give us the expected result. So that's false and 8. The difference is this, like, take note guys, if you find underscore update, it means that the change will take place in one of the sets. So no new set is returned. But if I do not use this update here, like, Python doesn't use the update in the name of that method, then it actually means that a value will be returned, a new set will be returned. So this here is just difference, not difference underscore update. So it's going to return a new set, which I have stored in new set. But guys, if I wanted to have the same result in place, that is mset3 is changed in place, then I need to use underscore update. I like naming convention in Python. It's, it's descriptive enough and consistent. So mset3 difference update. So it's going to just simply update mset3. Okay, so when, oh, sorry guys, no more new set. I should change this to mset3. So I run this. We see that we have false and 8. So that's the difference. The same applies for symmetric difference and symmetric difference updates. Let me use symmetric difference updates. Now, what's the symmetric difference? How is it different from the difference method? Great. For difference method, if I had A and I wanted to check its difference between, I want to check the difference between A and B. Then it takes all the values in A and looks for them in B, right? Anyone that is in A but is not in B will be taken, and printed to console in our instance here. That's the difference. But the symmetric difference is, okay, if I had A and B, then it's going to go through all the values of A, each of them, to check if it is in B. If it is not in B, it will take that value. Then it now goes through B, looks for, that value, or each of the values in B, looks for it in A. Now, if there's a value in B that is not in A, it takes it. So it's different both ways. A that is not in B, take it. B that is not in A, take it. Unlike difference, not symmetric difference now, difference. If I'm using just the difference method, it will just take what is in A that is not in B. It does not consider what is in B that is not in A. It just looks for what is in A that is not in B, returns that only. But for symmetric difference, it looks for what is in A that is not in B, takes it, and looks for what is in B that is not in A, takes it. So if I'm using mset2 and mset3, symmetric difference will return. Now we see that mset3 has 8, but it's not in mset2. It will take it. 8 will be taken. False is in mset3 only and not in mset2. It will take it. Now 9 is in mset2, but not in mset3. It will take it. So instead of only false and 8 as we had in difference, symmetric difference will now give us false, 8, that is false, that is in just mset3, 8 that is in just mset3, and 9 that is in just mset2. So there will now be 3 things returned. Okay, so let's see, guys, symmetric difference update. So it's going to update in place, going to update mset3. right? So when I print mset3, we'll see what it gives us. So we are right about it, guys. So this is false, 8, and 9. False and 8, they exist only in mset2, and then 9 exists only in mset. False and 8 exist only in mset3. Then 9 exists only in mset2. So those unique values in each of the sets will be, taken. Right. Now, what if I wanted to store what we get in a new variable? So a value is returned, a new set is returned. I am simply going to remove the update. So it's not updating an existing set. It's doing the check, but it creates a new set for the output. So that's I will call new set. So new set, and if I print new set, I see what we have there. New set. All right, so that's it, guys. All right, so to wrap up, I will just very quickly go through some methods just to do some checks. Maybe you are on a project and you need to do some checks using sets. I have the is subset and the is superset. So let's see, guys. Let me create mset 5 here, mset 5, and then I'm going to take this, just copy this, and then remove some values here. So just leave only 3, array and color. So we see that all the values in mset 5 are in mset 4. In other words, guys, mset 5 is a subset, a smaller version of mset 4. In a way, I have all the values in mset 5 present in mset 4. So mset 5 is a subset of mset 4, and mset 4 is a superset. That is the parent kind of mset 5. Is a superset of mset 5. Just like saying roses are flowers. So roses are subsets of flowers, and flowers are subsets of roses. I mean, flowers are supersets of roses. That sort of thing. Now let's see if that's the case. So I'm going to just store this in a variable and say mset 4. Then I'm going to ask, is mset 4 a superset? So is superset of, it takes a variable, a set there as it takes an argument, which here is a set, mset 5. Right. So it's simply going to check, is mset 4, this one here, is it a superset of mset 5? That's this one. And to return true or false. Oh, sorry, guys. Sometimes this can just be quite annoying how you forget some things like this. So that's check. Right. I'm going to print check. Right. So that's true. Really, guys. mset 4 is a superset of mset 5. But is mset 5 a superset of mset 4? Your guess is as good as mine. False. I mean, mset 5, this smaller one, cannot be a parent, like in terms of number of values, cannot be a parent of the larger one. If I wanted to have true as the output, then I need to change this to is subset. And I'll check. So that's true. So we see that mset 5 is a subset of mset 4. Right. Thank you, guys. Thank you so much for watching. I think that has brought us to the end of this lesson on Python sets. Okay. So, guys, if you have any questions, please leave your comments in the comment section. And please do not forget to hit the subscribe button for your videos on Python, right? I'm so happy being able to do this, and I really want you to hit that subscribe button. Thank you so much. I'll see you in the next video. Bye.